Welcome to section 414. We're going to be talking about mathematical modeling with parabolas. We're going to be talking about writing the equations. So if we look at the diagram of the jackrabbit jumping over a 3-foot high fence. So to clear the fence, the rabbit must start at a point that's 4 feet from the fence, and you can see it's jumping a total distance of 8 feet. So what is the shape of the path of the jackrabbit? You can see the path is a parabola. It's a parabola opening down. Now, if we sketch this on the coordinate plane, the way we would want to do this to make it easier for ourselves is to start the jackrabbit jumping at the point 0, 0, which means it would land at the point 8, 0. The vertex then, since it's going halfway, it's going a distance of 4 feet on either side of the fence, reaching a height of 3 feet. So 4, 3 would be the vertex. So the x-intercepts would be at 0, 0 and at 8, 0. The vertex would be at 4, 3. Now, there's other ways to do it, but this is the easiest way to do it, to have this jump starting at 0, 0, at the origin. Now, we're going to write an equation for the path of the jackrabbit. We could either write this in intercept form or in vertex form, that graphing form. Now, we still need to find A. We're going to use vertex form. And vertex form, y equals A times the quantity of x minus h squared plus k, where h and k are the vertex. So keep in mind, the vertex is at hk, and we need to find out what a is. We don't know it. So what we can do is we can use the vertex h and k and pick a point. So the vertex for this rabbit is at 4, 3, and we can pick a point, either the 0, 0 or the 8, 0. So a point, let's just pick 0, 0. Both will work exactly the same. So the vertex, that's our h, our k, and the point is our x and y. So y is 0. A we don't know, that's what we're solving for. X is 0. Minus 4 squared plus 3. So 0 equals a times negative 4 squared plus 3. 0 equals negative 4 squared is 16, so it's 16a plus 3. Subtract 3 from both sides. Negative 3 equals 16a. Divide both sides by 16. A equals negative 3 over 16. There's our leading coefficient. So y equals a, negative 3 sixteenths, x minus 4 squared plus 3. There's the equation to model this rabbit jumping over the fence. Now for this, our domain for the jump, we're starting, because our parabola is cut off, our domain is going from 0 to 8. So 0, x goes in the middle, and 8, and then we put our less than or equal to's. That's our domain. It jumped 8 feet. And our range, just for this model, it's going between 0 and 3. So 0, y, and then 3, and then we put our less than or equal to in between. So that's for our 8 foot horizontally. And the y is for our vertical. You jump 3 feet off the ground. So we could write so I'm not even going to worry about writing a different equation. I'm just going to stick with this one. I think it works better. But there are other equations depending on where we had it start at. So now, for number 2. Mrs. Bibby's kicking a soccer ball. It traveled a distance horizontally of 150 feet and reached a height of 100 feet. So remember, we're thinking about a soccer ball. Let's have it start at 0, 0. Now it's a parabola opening down. So it went 150 feet horizontally. So it's going to land at 150 and on the ground at 0. Now the highest point it reaches is 100. That's our y coordinate. Now the x coordinate is in between those two. So x equals 0 plus 75 divided by 2. 75 divided by 2, 0 plus 150. So it's 150 divided by 2, so it's 75. So the vertex is at 75 and 100. So to write this equation, we need our vertex at 75, 100, and we need a point. It doesn't matter if you pick the 0, 0 or the 150, 0. I'm going to use 0, 0 because the numbers are smaller. We need to solve for a. Y equals a, x minus h squared plus k. Y is 0, so that's our h, k, x, and y. 0 minus 75 squared plus 100. A times negative 75 squared plus 100. I'm going to subtract 100 from both sides. Negative 100 equals, and negative 75 squared is 5,625a. Then we divide both sides by 5,625. So a equals, and you can reduce this both by 5. I'm sorry, by more than that, by 25. So it's going to be a negative 4 over 225. That's our value for a. So our equation, y equals negative 4 over 225 as a fraction, x minus 75 squared plus 100. There's the equation of our parabola. So now we're going to go to problem number 3. At the skateboard park, a pool dips 15 feet into the ground and its widest is 40 feet. So what we could do, it's going down, it's opening up because it's going into the ground. Now, we know it dips 40 feet. So it's going down 40 feet. So we have our x and our y is 40. Now it's starting at 0, 0. And it dips 15 feet, not 40. I got them flipped. 15 is our y. And then it's going to 40, 0 because it's 40 feet wide. So for our x coordinate of the vertex, it's going to be 0 plus 40 divided by 2. So it's 40 divided by 2, x equals 20. So it's at 20, 15. Once again, our vertex is at 20, 15. That's our h and k. And a point is at x and y. 0, 0 is what I'm going to use. So y equals a, x minus h squared plus k. So 0 equals a times 0 minus 20 squared plus 15. 0 equals a times negative 20 squared plus 15. I'm going to subtract 15 from both sides. Negative 15 equals negative 20 squared is 400. A. Divide both sides by 400. And then we can reduce. A equals negative 3 over 80. Oh, sorry, that's a... see a mistake. K is at negative 15. So it should be a minus 15 at the end. So then we're adding 15, and that's why it's a positive 15. The reason I knew I made a mistake is because it's opening up. A has to be a positive. So keep that in mind. So y equals a, which is 3 over 80, times x minus 20 squared plus, minus 15. And there's the model for that skateboard ball. Number 4. Now, number 4, we're given the equation, and this is actually in that intercept form. What we really have here is y equals negative 0.001 x minus 0 times x minus 260. That's intercept form. So now, we need to find the vertex. Because it says x is the horizontal distance in yards, and y is the height. We don't know the height. All we know is that this golf ball starts at our intercepts at 0, 0, and ends at 260, 0. Now to find the vertex in intercept form, we can add up the x's. X equals p plus q, the intercepts, and then divide by 2. 0 plus 260 divided by 2, so x equals 260 divided by 2, which is 130. Then we find y by substituting into the equation. Negative 0.001 times x, which is 130, times 130 minus 260. Negative 0.001 times 130 times negative 130. So y equals 21.754. So, 16.9. So now the ball traveled 260 yards. That's the horizontal distance. And the maximum height, that's our y of the vertex, is 16.9 yards. Let's go to the next one. Number 5, our last one. A punted football. The leading coefficient's negative. Not only that, but you know the flight of a football, it goes up and then back down again. Now, we want to find out what the maximum height is and how far the ball traveled. We don't know that. This is in standard form. So what we need to do is we need to find the vertex first. To find the vertex, x equals the opposite of b over 2a. So it's going to be negative 1.196, all divided. And make sure you put your parentheses in, your denominator in parentheses, 2 times negative 0.026. So when you type that in your calculator, you get x equals 23. Now we want to find y. Negative 0.026 times 23 squared plus 1.196 times 23 plus 8. So you get y equals 21.754. So the vertex is at 23 and 21.754. Now, remember, the vertex is in the middle. So it took us 23 yards to get to the middle, and we have to go another 23 yards to get back to the ground. So think about us starting at 0, 0, and we're ending at a total distance, not of 23, but 46 yards. And then back to 0. So the maximum height, the y of the vertex, is 21 point, and I'm just going to round it to 8 yards. And the distance traveled is 46 yards. And there's our information from that equation. Okay, that is it for section 414. Thank you, and I'll see you in the next video.